Welcome. This is going to be a short introduction video on how we solve equations. Now this chapter there's going to be 3 guiding questions that take us through the entirety of the chapter. First, how do I know when I am done? This is going to be an important question and something that we can get into further detail come next section. What does my solution look like? And that comes into the category of how you know when you're done. You have to know what you're looking for to know if you're done. For our purposes, the solutions to equations generally look like this. X equals 4, x equals minus 10, x equals something. That we've whittled it down out of the total number of possibilities that x is definitely this number. How can I even be sure that my answer is correct? We talked about this last chapter. What you would do is you would plug it back in. Plug it back in. So in just a moment we're going to try out some very basic equations and we're going to see what our general principle is for solving these. Our general idea when solving equations is to isolate the variable, and what that means is to get it to look like what we want. We want it to be x equals 4, x equals minus 10. The x is completely isolated. There's nothing else around it whatsoever. In these examples you can see there's a lot of things happening to our buddy x. He's being added by 3, he's being multiplied by 2, he's being subtracted from 8, and this is no good. We want him to be all alone by itself. And the way that we can get our variable isolated is to apply the inverse operation. Now, all operations in math come with pairs. If you do something, you have to be able to undo it. Addition, subtraction, that's a pair. They undo each other. Multiplication, division, that's another pair. Squaring and square rooting, the list goes on and on and on. But the reason why we want to think about the inverse operation is it's going to remove what we see. So take a look over here with our x plus 3 equals 10. If I added 3 to both sides, that would be no good. I would get x plus 6 equals 13 because that 3 and that plus 3 would combine together and the 10 and the 10 and the 3 would combine together. And this is no closer to having that x isolated. That's because we didn't use the inverse operation. So since I see plus, the inverse operation of plus would be minus. And by taking 3 away, aha, we've gotten the x all by itself. 3 minus 3 equals 0. And x plus 0 is really just the same as x. So we have completely isolated it, and now we know, hey, that's our solution. But if you wanted to double check, is this solution correct? You would go back in and say, well, 7 plus 3, what does that give me? Yep, gives me 10. Pretty confident my solution's correct. Here, when we see the 2 and the x all next to each other, that's an implied multiplication. So to undo multiplication, we have to use division. So this would isolate my x, and now I just need to figure out what 24 divided by 2 would be. And, well, it's a dozen. It's 12. So x equals 12. You could check your answer by plugging it back in and seeing that you get 24. Now our third example over here, we have x minus 8. So now I want to think about how to undo minus, which would be a plus. So if I add 8 to both sides, again, this minus 8 and this plus 8 are going to take care of themselves, and we'll just be left alone with the x. Now we need to figure out what a positive 8 and minus 2 look like when combined together. That's essentially 8 minus 2, which will give us 6. So the goal when isolating your variable is to try to scan the equation, see if you can pick out which operations are there, and apply the inverse operation. I have some more examples right here. I would certainly hope that you guys take this opportunity to pause, try it out, see if you can spot the inverse operation, apply it to both sides, and tell me what you get. So I'm just going to hold on for a few seconds. If you haven't paused, seriously, go ahead and do it. Okay, so now I'm going to try these out. For the first example, I see 4 times x. I can undo a times with a divide. In dividing both sides by 4, I get x equals 5. Over in this equation, I see x plus 6. I can undo a plus 6 with a minus 6, and that gives me x equals 7. Over here on the middle left, I see x minus 15. You can undo minus with a plus. That will give you x equals 40, the biggest answer so far. Now, I didn't talk about this yet. Fractions are a more efficient way, let's say, to represent division. I think I've mentioned this to some of you in the past. You will very rarely see this symbol anymore. We tend to move away from it because fractions are more useful and they actually help us see order of operations a lot easier. So x divided by 8. I can get rid of that with a times 8 on both sides, which leaves me with an x. 3 times 8 would be 24. Now over here, it's plus x, but I don't want to undo the x. I want to find out what the x is. But that's 17 still positive in front. So I've got essentially a plus 17 right here. So I can take away 17. And now I've got a negative minus a 17. That's going to get more negative. I think I've lost negative 28 total. And this very last one, we've got a times 3 right here and a plus 5 right there. There's 2 operations going on in this one. I'm going to have you guys try this one on your own and tell me about it in person later. I want to see what you guys are thinking. Think about what would be easier to undo first, the times or the plus, and try it out. Plug it back in and see if you actually get 17. Thank you for watching, and I will talk to you all later.